The best way to level up as a security-minded blockchain developer or security auditor is by watching other security engineers work and learning from how they tackle a code base. But oftentimes, of course, unless you manage to join a team of skilled security engineers or just so happen to work alongside some of the top tier security researchers in the space, it can be hard to get a chance to peek over the shoulder of a fellow auditor. And that is, of course, why I decided to make this series where we live audit a set of smart contracts for Filecoin alongside their research engineer, Denis, who has nearly 2 decades of experience in cybersecurity and blockchain technology. And so in this series, you have all the context on the smart contract system that I have, and we walk through the system together as Denis explains what the system is doing, and we try to uncover bugs and vulnerabilities as we go. And so last episode, we were just getting started diving in, seeing how validators can join the system and exit the system, and we found a few initial nice little bugs as well. And in this episode, we're going to continue to dive deeper and start to begin to understand this contract system at a deeper level and hopefully uncover some more cool findings. First, before we begin, of course, my name is Owen, and over a year and a half ago, I founded Guardian Audits, and ever since then, we've uncovered dozens upon dozens upon dozens of critical and high vulnerabilities with at least easily over 1,000 hours spent auditing smart contracts myself. And of course, my goal with all of these videos that I put out, and especially this new series, is to distill down everything that I've learned along the way about auditing smart contracts and complex financial applications and give it to you so that you could ultimately become a much better security engineer, blockchain developer, whatever it is you want to be in a fraction of the time while avoiding all of the obstacles that I had to overcome along the way. All right, so without further ado, let us dive right into the auditing. Let's have a quick look at kill and how that works from, I assume we have to go through the subnet actor to kill it, right?
Yeah, absolutely. So the same modifiers except non-reentrant. So here, what I don't like personally is that here we use address this balance.
Mm-hmm.
And if it's greater than 0, then we revert. And if there is a validator, so if not all validators left the subnet, and we should not kill it. Otherwise, we change the status to terminating and call the kill method on a gateway. And so that's a minor. There is one minor issue with that, is that an attacker can send.
Yep.
In theory, can send some money to this subnet actor, and it will not be possible to kill the subnet at all.
Yeah, exactly. And then it has to be, there's no way to remove it from the gateway then, right?
Yeah.
Okay, yeah, I think that's a fantastic thing to note as well. Yeah, I mean, they could even literally send like one way. It doesn't even have to be a significant amount. All right, great. So that's like a complete denial of service. And there's no way to just like withdraw ether from this. I guess we'll get into that because I think the reward function will do something like that. But yeah, let's continue on and look at kill first, and then we can get into like rewards and stuff like that.
Kill existing subnet. Yeah, and the requirement here, so the balance must be empty. So the attacker must the attacker may send something, and this requirement will not be satisfied. Okay, so we do the same. We get a subnet by sender ID, check whether the subnet is registered or not, and then we check the circulation supply. If it's more than 0, then we revert. Otherwise, we decrease the number of subnets because we're gonna kill one, delete subnet, the target subnet, identified by its hash from a subnet mapping, and send stake to the subnet actor.
Got it. So at this point, the subnet is entirely removed from the gateway system.
Yeah, but from business logic perspective. But yeah, so do you mean that here we actually don't remove the subnet? I mean, we remove it, but the data will still be in that mapping, right?
Well, no, that should actually sufficiently remove it, unless, I mean, depending on what is in that mapping, if we have like a dynamic data structure. But no, I think that's completely fine. This actually looks good.
Because subnet is a structure.
Yeah, let's have a look at what is in the subnet struct here. So let's see. I'm interested. So I know the status. Okay, that's just an enum. That's fine. The ID is interesting because I know in the ID you guys have a root.
Subnet ID is the concatenated name containing the path from this network to the root network. Yeah, but potential problem is that this structure, this type can still have cross messages and checkpoint. So when we delete it, we don't erase the actual data, right, in a storage.
Yeah.
And if then we create this subnet with the same ID, then these fields will not be empty, right?
Yeah, exactly. So we need to look into, or maybe we can just leave a note that we want to look and see if I can if I kill a subnet, can I reactivate it, right? Re-register it with the system. And I assume we can, right?
Yeah, of course. Nothing stops you from that. There is no logic that you just get the same subnet.
Got it. Yeah. So that will definitely be something we want to note.
Yeah, but so that's a potential problem because and it's not so easy to understand how the stored persistent the messages can affect the protocol flow for checkpoint protocol and for cross messaging protocol, because these data are used for checkpoint from children to parent, and cross messages between two arbitrary subnets in the system, in the entire network. So maybe that's worth knowing.
Yeah, absolutely. Yeah, it's definitely something that requires like broad knowledge of what is the system doing with each one of these, right? Okay, great. And then the other question I had about kill was related to the circulating supply. We're always going to require that there's zero circulating supply if we want to kill, which makes sense, right? But is there a way, and we haven't covered this area yet, but is there potentially a way where I can like cause the circulating supply to like be non-zero so that I can DOS anybody trying to kill this or something like this? Similarly to how you said, like, we can just send ether to that contract and DOS the kill. Is there a way to have circulating supply always be remaining on the subnet?
Yeah, so circulation supply is increased when we fund the addresses on that network. So, for example, if I have an account in a root network, and the subnet A is a child subnet of the parent, and I just can call fund method here and send my money from the parent, from root network to subnet within the same account. So I can have different accounts in different subnets, right? And if I wanted to send my tokens to the subnet, I call fund method on the parent network. I specify the target subnet ID, and then by design, this will increase the circulation supply, because we want to track the circulation supply, and by design or there is a requirement that says that it's not possible to withdraw more tokens from the subnet than we send to that net. If we send 100 tokens, then the maximum allowance for us is 100.
Right. And so I saw that fund function. So the fund function is payable. So really when I want to send the native token to another subnet, I have to first send those native tokens to this gateway here. And then this gateway will basically hold on to the native tokens on this subnet and then basically transfer those to the different subnet.
And this will be propagated using the hierarchy, bottom up or top down.
And so is it accurate to say that the total amount of native tokens in the system, is that limited to the amount of native tokens that are basically sent to the gateway contract on the root? So in other words, for every circulating supply in a subnet, does that correspond to an ether on the root network?
No, tokens sent to the target subnet from any subnet to this subnet. It can be parent, it can be a root network or non-root network, sibling network, it doesn't matter. But if we send some tokens to the subnet, then it will be accumulated in a circulation supply variable.
Got it. So if I have a root network and then I have a subnet under it, right? And let's say like the root is Ethereum, then if I want to send funds to my address on the subnet, I take like 5 ether on the root network, send it to the gateway there, and I call fund for this subnet. And then now on this subnet, now I have 5 ether, right?
Yes.
And then if I want to unlock that ether, I can just send that 5 ether back on the subnet, and then I unlock it on the root.
Yes, you call a release. You call a release method, and then you get them back on it.
Okay, great. And that's exactly the firewall principle, is that I can never, since we're using circulating supply like this, I can never end up withdrawing more than what was, initially put into this in the gateway.
Yes. Because the logic behind that is that the subnet implements an arbitrary consensus protocol, so users can choose a protocol whatever they want, and that protocol can be insecure. And if this protocol is totally compromised, we don't want to that insecure subnet affects the entire system, other subnets at all. And because of that, we have a firewall. We have to have firewall property or firewall mechanism for each subnet.
Yeah, so it's on a subnet basis, right? Yeah, that's an important detail, because the gateway has, n many subnets, could be sending funds to the gateway to get, funds onto those subnets. So we firewall them on a subnet basis. And is it just on a subnet basis, or is it also on an account basis?
Only just for subnet.
Okay. So that would be an interesting attack vector to think of. Like maybe this is something as well to note down, is there a way we can still follow the firewall sort of principle, but I can have one account essentially be able to take money that a different account deposited? And is that any sort of attack vector? Could that potentially happen in the system somehow, where, like, for example, if I had, let's say I'm address A on the root net, and I send 5 ether to the gateway, and we go on to the subnet, and 5 ether gets set out on the subnet. Is there a way for address B to come in on the subnet and somehow get that 5 ether out on the root net that was dedicated for this subnet and send it to address B on the main net?
So count A send 5 tokens from root network to a parent network, to a subnet A, right?
Yeah, exactly. So now subnet A has those 5 tokens.
Circulation supply is 5. Then B, if I understand correctly, send 5 ether from a subnet to his account on a root network, right?
Mm-hmm, mm-hmm.
And okay, and then so from a firewall perspective, all fine, right?
Yeah, so firewall, this completely follows firewall. And I'm actually interested in this because, and I mean, you can tell me where my logic is flawed or what I'm missing, but let's say we have a mainnet, like a root, and then we have a subnet, and then we have a subnet under that. So in this scenario, when we have three subnets or three networks, in this parallel structure like this, let's say this person, Alice, on A, they send 5 ether, 5 real ether on the root. They send that and they go all the way down to the subnet at the bottom, right? So now there's 5 ether circulating supply on the subnet all the way at the bottom.
Sorry, do you mean this structure?
Yeah, exactly.
Yeah.
So then what happens, and I can even pull up a whiteboard and we can map it out if I'm not explaining it perfectly, but that right there, that makes perfect sense to me. So if I have Alice on the root network, she sends 5 ether to the gateway on the root network. It goes all the way down to C.
Mm-hmm.
Now Alice has 5 ether. The circulating supply on C is 5. Then now Bob is on A. And he says 5 A native tokens to the gateway on A, and then he sends those down to C. So now Bob has 5 native tokens on C. Alice also has 5 native tokens on C.
Mm-hmm.
Then could Bob do this where he sends those 5 C tokens back and he wants to basically fund the root, and he wants to take out 5 ether? Is that something that's possible?
But if Bob sends 5 tokens from subnet A to this subnet /root/A/C, that means that he had 5 tokens on a root subnet.
Okay, got it. So every token on every subnet is tied to real ether on
Yes.
the main root network. Okay.
Yes. Yeah.
So they all have that inherent worth of they can all be exchanged on the root network.
Mm-hmm. Mm-hmm.
Okay, got it. Yeah, that makes sense. Yeah, I think we're good then. I think let's move on to rewards because I think we'll go and look at rewards. And so this is an interesting function because it's called from the gateway to the subnet actor, and it's kind of a side effect. Is that correct?
Yeah, that's correct.
So what are the scenarios in which a reward is triggered from the gateway?
The goal is to reward validators that send cross-net messages between different subnets.
Okay. So if we walk through this function, I'm saying, okay, we get the validators link.
Sorry. So here we saw actually when we call fund and release, then there is a cross-message fee.
Got it.
And those fees are accumulated and can be distributed among validators using reward function. So that's the goal.
Okay, so if we actually go back to the gateway really quick, when you look at that distribute rewards function, what does that underscore distribute rewards function do? Yeah, in the gateway contract, there's that function, that internal function on line 362 or 367.
Okay, so that function calls reward function.
Okay, so we always...
So in this case, the gateway is a caller, and this function is callee function.
Okay, so is it possible actually that you mentioned there's like a minimum reward, right? Like there should be enough rewards to distribute.
Mm-hmm.
So there's a few interesting things going on here. So let's see. So first of all, we're checking if message.value equals 0, then we just revert that. I'm immediately thinking, is there some way that we could get the fee to be 0, and then if the fee were to be 0 in this case, it would be a complete denial of service, right? I wouldn't be able to send cross-chain messages at all.
Okay, so what we call it in release and fund, right?
Mm-hmm.
Okay, fund, right? So fund,
right,
and commit child check, also commit child check. So we've called fund, and then we call distribute rewards, and cross message fee is a constructor parameter. So if it's zero, then the reward is also zero. So at least if the cross message fee is zero, then it means that the fund method it doesn't work.
Yeah, so I guess that's more of a configuration thing. I don't know in the constructor if you require the fee to be greater than zero.
Let's check. Cross message fee. No, we don't require.
Okay, so just something to note that obviously we shouldn't deploy it without like any message fee or something like that. One thing I think it might also be just a precaution, maybe to transform the reward function to, instead of just reverting when there's no rewards, just like an early return or something like this.
Mm-hmm.
Or maybe even better, to be even more defensive in the gateway against like any sort of implementation in the subnet actor contract. In the gateway, we could only call that function if there are rewards to be distributed, right? So in that internal function, it could be like, if amount greater than zero, then we actually call this, or something like that.
Yeah, definitely. So we're in a gateway after distributed words, and here where's this check? Yeah.
Okay, great. So we already have that. That's fantastic. So we can go back to the rewards function then. Okay, let's see. Okay, so this is interesting. We're getting balance, and then we're saying if balance less than validator's length, revert. So that's literally comparing it in like way. So we're saying if we have like 7 validators, there should be at least 7 way. I suppose that's fine. We're just avoiding like some potential rounding error.
So it's fine from Solidity perspective, but actually that's not fine from a protocol perspective, because what it can be is that so if a malicious validator joined before calling a reward function, then and it even did not participate in those message routing process, it will get a reward. So that's not good from a protocol perspective, right?
Yeah.
And but that's that's the design flaws, right? Another thing is that we also should understand whether rewarded validators really took part in those epochs where they send cross message networks or not. So in ideal case, I would say that should be a kind of, so epochs and rewards must be linked somehow. So in those cases, we would, if a gateway calls reward function, then we should understand that there are 4 validators. They were active. They really sent messages, and this reward, and they should get rewards for routing those messages. So
yeah,
kind of something like that.
No, that's a very good point. I think that absolutely it's implementing it by epochs and deciding, was this validator here for this epoch or something like that. That could work. There could also be like a minimum time requirement or something like this. We're going through a for loop here. So we could even do something where we do sort of like a like we briefly discussed, like a per share sort of approach, where instead of even having the for loop, you could increment like and this could even be tied to the epoch. So an epoch, validators are there validating for a specific epoch. They could join at epoch number 1, right? Then for example, in that epoch, a certain amount of rewards are supposed to be distributed for that epoch, right? So we could only allow validators who are stamped with that epoch or earlier to come in and claim rewards for that epoch. And so what the reward function could look like is, instead of divvying up rewards to specific validators, instead you divvy up rewards for a specific epoch, and then the validators could come and claim their rewards for an epoch or something like that. There's probably a better way to do it than that, but something interesting, yeah, exactly like you're saying. But I actually think that there's something even more nefarious going on with this function after you note that down. Yeah, so I'm noticing that we're divvying up the entire balance of this subnet actor contract, right? And we're just distributing it to all of the validators in the validator set. But remember, in the beginning, we were sort of digging into and understanding that this contract also holds funds for collateral that hadn't necessarily been moved into the gateway yet for those people who sent money, but they didn't send just enough to get over that minimum threshold, right?
Mm-hmm.
So potentially we could be taking those people's funds, those people's collateral that they sent here, but they weren't able to get over the minimum threshold, so their money's still here, or maybe it might be in the gateway, but I think there are cases here where people's collateral is in this subnet actor contract, and perhaps it's being divvied up by this reward.
Yeah, so even they are not validators, their stake will be divided through all validators.
I think possibly. I think there is an edge case where that could happen.
Yeah, but that's possible only if we did not fix that bug, right? If we fix them, then there is no such, they will don't have such opportunity, right? Because we believe that, this is the bug, right? If we fix it, then it will not be possible to join the network without adding into validator set, because that's incorrect.
Yeah, exactly. Like, I'm thinking as long as the invariant should be that there's no way to have funds here that are not meant for reward distribution.
Yeah, so that's another consequence of the previous bug in the system.
Yeah, and also the changing of the reward distribution might fix that as well, right? To the point where we're not just reading the balance of this address and distributing the entire balance. Now we have some sort of epoch logic or something like this. Yeah, I think that is everything for this function. Is there anything else? Okay, great. And it's non-reentrant and only gateway, of course. That's pretty much like the managing of validators and stuff like this, right?
Mm-hmm.
Okay, great. So that's like everything related to validators. We know how to join, we know how to leave, we know how to kill, and we know how these rewards are being divvied up, right?
Correct.
Okay, great. So then the other portion of the system is everything to do with these like messages and commitments, right?
Yep.
And I think so. If we look at the interface for the subnet actor again.
So from interface perspective, it's in a subnet actor we have only one function called submit checkpoint. Submit checkpoint. It's external, and we call submit checkpoint with a bottom-up checkpoint, and that's it. So bottom-up checkpoint means a message. So bottom-up checkpoint is a type that is used to send messages from bottom to up.
Yes.
In a hierarchy. The reason why the direction isn't the type name is because we have two different flows, bottom up and top down, and messages within these flows are processed differently. So there are three ways actually, right? Bottom up if we send a message from children to a root network in the direction of root network. Top down is from root network to children, to leaves of the tree hierarchy. And the other way is it's called path, and it's a mix of bottom-up and top-down messages. So in this case, it's possible to send a message from absolutely different subnets on hierarchy.
Got it. So this submit checkpoint is we're just going straight up to basically checkpoint with ultimately the root network, right?
Yeah.
All right, fantastic. That is all for this time. We've got a lot of great findings here, and we're starting to really dig in and understand this code base and get comfortable with the system. Now, in the next episode, we're going to continue to dig in and uncover some even more interesting findings and vulnerabilities and attack vectors. But I want to know, what was your favorite part about this episode? What was your favorite finding or, audit tag that we made? And did you notice anything that we didn't that maybe ought to be flagged for the team? And of course, if you happen to be on a team that is building a really cool new DeFi application, then of course I want to know about your project. I want to know about it so much that I'll do a free first pass initial security notes of just some things that you'll want to get fixed before you go into an audit. When you apply for an audit, quote at guardianaudits.com/quote. And of course, if you happen to know anybody who is looking for a smart contract audit, then send them on over to guardianaudits.com/quote. And of course, if you are interested in up-leveling your skills as a security researcher or a security-minded blockchain developer, and you're interested in connecting with folks from around the world to learn from their experience in the security world, and potentially even team up with others to compete in real audits of real code bases and even get rewarded for your findings, then go ahead and apply to join our free community of smart contract auditors at lab.guardianaudits.com. All right, that is all for this time. I cannot wait to see you in the next one.